Okay, hello. So, this is the 3.2 worksheet, and as always, I'm gonna try to explain it as best as I can, and hopefully, I don't make it more confusing for you, but it helps. Yeah. So, for number 1 to number 3, we are going to be using the techniques or like the types of problems that we're gonna be solving are like the first ones that we have in our notes. So for the first problem, for number 1, our answer is gonna be 1 over 90 because the amount of numbers that we have between 10 to 99 is 90. So like the amount of 2-digit numbers that we have between 10 and 99 is 90. And we are looking for the probability that when we pick a random number, the number that we get is 32. So since we can only get 32 one time, since 32 only appears once between 10 to 99, it would be 1 over 90. And then for number 2, we are looking for the probability that an odd number comes out. And so we would have to figure out how many odd numbers there is between 10 and 99. And you could basically do that by dividing 90 by 2, since there's always even and then odd numbers. So then it would be 45 over 90 and then equals 1/2. Then if you are kind of confused about how to solve for the odd numbers, like how to figure it out, you could always just think about each number separately, I guess. Like even though that would like take a lot of time, you could just go down the list, I guess. But just to make it easier, you would divide 90 by 2. So yeah. So then for number 3, in this case, we would have to find how many numbers there are that are a multiple of 5. And again, you could go down the list of the numbers that we have available and like think about whether they're multiples of 5. So like 10 is a multiple of 5 because 5 times 2 equals 10. And then 20 is also a multiple of 5 because 5 times 4 is 20. So like you could go down the list and like think about each number individually. But that's gonna take a lot of time. So you could just divide 90 by 5, which gives us 18. So then that means we have 18 numbers available to us that are a multiple of 5. So it would be 18 over 90, which would equal to 1 over 5. And that would be our final answer for number 3. And then for number 4, we are going to be working with this word right here, which is candlestick, and it has 11 letters. So like for number 4, we are looking for the probability that we randomly choose a vowel. So we would count how many vowels we have, and it is 3. There's 1, 2, 3. So it would be 3 over 11, because the bottom is always going to be the total amount of possible outcomes. So it would be 3 over 11. So then for number 5, it says that we're looking for the probability that we randomly choose N or S. And since these are 2 different letters, our top number would be 2. And then our bottom number would be 11 because that's the total amount of words, the amount of letters that we have. And then for P, we're looking for the probability that it is not C, the letter that we choose, that we randomly choose. So since there is 2 C's, we would subtract it from 11 to figure out how many letters we have that are not C, or we can just count it. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. And the 9 would be our top number. The amount of letters that we have that are not C would be your top number, and then the bottom would be 11 again, because that's the total amount of letters that we have. And that would be it for those first problems. Sorry again if you hear background noise, screaming. Yeah. So then moving on to the other problems, we are now going to be solving word problems, which can be a little bit more tricky or like difficult to think about, but we have to do them. So what are we gonna do? I'm just kidding. So then so number 7, it says 3 coins are tossed. Find the probability that 2 land on heads. So for this one, like we had to do in some of our notes, we would have to think individually of how many outcomes we can have. So like just like how Mr. Elip was writing like outcome by outcome by outcome on the board, and like it was a bunch of different outcomes, we would kind of have to do the same here. So we would have to think about how many different outcomes we have. So like if we toss 3 coins, there's a probability that all of them land on their head. However, we don't want that. We only want 2 to land on their heads. So that's one possible outcome, but it's not the outcome that we want to have. So another outcome would be that all of them land on their tails. That's another outcome, but it is not the one that we want. Another one would be that 2 land on their tails and then 1 lands on their heads. That's not what we want, but it's a possible outcome. And then there could be that 2 land on their heads and only 1 lands on their tails. That's one outcome, one possible outcome, and it is also one that we want to have. So we would count that as like one of the ones that we want, and then we would add it to the ones that are possible. And then another possible outcome could be that, let's see, that, so we said these are all tails, and then these are all heads, and then this is tails, tails, heads, and then this is heads, heads, tails. So then it could be tails, heads, tails, and then it could be heads, tails, heads, which would also give us 2 heads. And then it could be, what did we say? I'm sorry, this is kind of confusing. This is a lot of mental work. So we said tails, 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 and then heads, 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 and then I think we said tails, tails, heads, and then heads, heads, tails, and then heads, tails, heads, okay, and then it could be tails, heads, tails, and then it could be tails, heads, heads, and then heads, tails, tails. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the possible outcomes we can have, it's heads, 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 and then tails, 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 and then heads, tails, tails, and then tails, heads, heads. And then we could also have tails, tails, heads, and then heads, heads, tails, and then tails, heads, tails, and heads, tails, heads. And then, yeah, so that would be the outcomes that we can have. I guess it was easier to just write it down instead of using tally marks. But yeah, so we would have 1, 2, 3, 4, 5, 6, 7, 8, and we would have a total of 8 outcomes. That's the total amount of outcomes that we can possibly have. And then we want to have outcomes that include 2 heads. So that would be 1 and then 2 and then 3. So we have 3 possible outcomes that we want. So that would give us 3 over 8. Yeah. So then number 8. Number 8, it says a month is randomly chosen. What is the probability that the month chosen has less than 31 days? So for this one, we would have to figure out how many months in the year have less than 31 days. And that is 5. 5 months have less than 31 days, and then the total amount of months that we have is 12. So it would be February, and then April, and then November, and then June, and then March, I think. Yeah, but it's 5. It's 5 months that only have 30 or less days. So our probability would be 5 over 12. So sorry again if you can hear screaming in the back. But yeah, little kids. So yeah, that would be our final answer. It would be 5 over 12 because there are 5 months that have less than 31 days, and we have a total of 12 months in the year. Moving on, number 9. So for this one, I really hope that he doesn't make us do any type of card questions in the test, because I'm not really like knowledgeable about decks of cards and like playing cards. But yeah, so at least, I mean, I've been learning through these word problems. So like basically what I've understood is that there are 4 cards of each number in the deck of cards, and then there are 13 cards of each type of card. So like, what's it called, like diamonds. There are 13 cards that are diamond, and then there are 4 different cards that are nines. So then we would write the 52 on the bottom because that's the total amount of cards that we have. And then the 16 would come from the 16 would come from adding the 13 and then the 4. So like the 13 cards that we have that are diamond, and then the 4 cards that are 9. And then we would subtract. So we basically have 13 cards, right, that are diamond, and then we have 4 cards that are nines. However, we have to look for the probability of drawing a 9 or a diamond. So since there is a card in the deck that is a 9 and is a 9 and it's a diamond, it's a 9 of diamond. I don't know how the cards are called, but yeah, there is a card that is going to be 9 and also a diamond. So we're gonna subtract that one from the equation. So it's gonna be 13 plus 4 equals 17 minus the 1 equals 16. So yeah, and then we would simplify the equation, which is gonna be 4 over 13. Yeah. And then for number 10, it says that the cards have a 3-digit security code, and then what's the probability for the code to start with the number 7? So we know that there is 10 possible like digits that could be like placed because they go from 0 to 9. So the bottom, the total amount of outcomes that we could have is 10, and then the top would be 7, because 7 only comes up once between 0 to 9. Again, I'm sorry for the screaming. It's kind of distracting me, so I'm sorry. So if even you can hear it, I don't even know if you can, but if you cannot, yeah, they're screaming going around. So yeah, this would be our final answer for number 10. And then for number 11, it says 2 dice are rolled. What is the probability of not getting doubles? So when 2 dice are rolled, our possible, like our total possible, the total amount of possible outcomes is 36. 6 times 6, 36. And so we have to see how many times it is possible that we get doubles. So like doubles meaning that when we roll 1 dice, we get a 1. And then when we roll another one, we also get a 1. So then, so the numbers, the possible outcomes that we can get when we get doubles would be 1 to 1, and then 2 to 2, and then 3 to 3, and then 4 to 4, and then 5 to 5, and then 6 to 6. So that would be 1, 2, 3, 4, 5, 6. So it would be 6 over 36. And then it would be 1 over 6 when we simplify. So then for number 12, it says, what is the probability that the next song that plays is not Katy Perry? For this one, we would have to do the complement of an event theory, or what's it called? Work technique, math technique. So like this one and the bottom. We would have to do something like that. So it would be, first we would write the 1 minus whatever we are subtracting. We would be subtracting the Katy Perry songs. So it would be 1 minus 17, which is the total amount of Katy Perry songs that we have, and then over the total amount of songs that we have in general. So like 14 plus 16 plus 17. So it would be 14 plus 16 plus 17, which is 47. So then that would be 30 over 47, and that would be our final answer. And yeah, that would be it. So then for number 13, we are now going to be dealing with the compound probability, which is the backside of our notes. And I'm pretty sure we're gonna have to decide whether it's dependent or independent. Actually, no. The ones that have the little parentheses are gonna be the dependent events, because we have two events happening in a single like probability. And then the ones that are just like this, I'm pretty sure those are gonna be the independent events, because yeah, that's how they look in the notes. I'm pretty sure it's gonna be like that. So let's see. 13 says a dice is rolled, then a coin is tossed. What is the probability of getting a 5, then tails? So since we are dealing with independent events, we would be multiplying the first event by the second event. So we would figure out the first event first. So it would be getting a 5. So since we can only get a 5 once, it would be 1 over 6, because a dice has 6 different probabilities, I guess, in total, but we're trying to get a 5, and the 5 can only happen once. So it'd be 1 over 6 times the tails, which would be 1 over 2, because there's half a probability that we get tails. So then after we multiply, it would be 1 over 12. And that would be our final answer. So then for number 14, it should be like that as well. It says a coin is tossed. Then a number 1 through 10 is chosen at random. What is the probability of getting heads? Then a number less than 4. So first we would solve for the coin being tossed. It says what's the probability of getting heads? It would also be 1/2. So then for the random number, it would be, since we are doing any number less than 4, it would be 1, and then it would be 1, 2, and then 3, because those are the numbers less than 4. So it would be 3 over 10, because that's the total amount of numbers that we have. So it would be 3 over 20 as our final answer. And yeah.